Hey, good morning, my fifth graders. All right, so bear with me today because I'm recording on my own as well. I don't have a videographer today. Alrighty, so hope you guys are doing great. Hope you've had a chance to look over this test. We're going to start off with just multiplying and dividing fractions. I'm going to show you the model first, just for the first one, and the first multiplication one and the first division one. And then we're going to just go to the rules and what you do. So for example, this one right here, if I was going to demonstrate 1/3 times 1/4, I would first want to demonstrate 1/3. So I'd split that into thirds and I would shade in 1/3. Just imagine all those are equal sizes. They're not quite. And then I'm going to multiply by 1/4. So I would need to then divide that into quarters. And I would then shade in one of the quarters. And so I'm just going to shade in that one right there. And our answer is where they are both, whatever boxes have two shadings in them. Can't really see my different colors there, but we can clearly see that this one right here has purple and red in it. So that is one of the boxes out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The answer is 1/12. All right. So let's just do the rule there. Let's look at it. All right, we have, our rule is we multiply the numerators, 1 times 1 is 1, and we multiply the denominators, and 3 times 4 is 12. And that's our other way to get 1/12. This is the way we want you to do it, because this takes time. If you take too much time in tests, you might not be able to finish all the problems. So this is just to see what we are actually doing, but we definitely want you to move to this method right here. So for this one right here, we're just going to use the rules. All right, so we have 3/4 of 1/3, and we know in math the word of means times. So we're just going to do the same thing. We're going to times the numerators. 3 times 1 equals 3, and 4 times 3 equals 12. We then look at that problem and we see, can it be simplified? And yes, there is a number that can be divided by both 3 and 12, and that is 3. So we could do 3 divided by 3 and 12 divided by 3. And our final answer is 1/4. All right, some of you could have simplified that fraction first and got the 1/4 immediately. So let me show you how you would do that. So we could take and we could do 3 divided by 3 here, and that would be 1. And if we're going to divide by 3 on the top part, we have to do it down here as well. And there we are there. 3 divided by 3 is 1. 1 times 1 equals 1, and 4 times our 1, and that is another way to get the 1/4. All right, so let's look at C, trying to find C here. There we go. All right, let's just follow the rules there. All right, we have 3 times 3 is 9, and 4 times 5 is 20. We then ask ourselves, is there a number that can be divided by both 9 and 20? Hopefully you're saying no, because that is it. That is the final answer. The answer is 9/20. So here's our division one. Let's look at and think of a diagram first. All right, so we're doing 4 divided by 1/3. So I'm going to make one big box that represents my 4, and I'm going to split it into 4 parts. So I've got 1, 2, 3, 4 parts. All of this represents 4. All right. So I then need to divide all of those into thirds. All right, so I'm going to do 1/3 in that one, 1/3 in that one, 1/3 in that one, and 1/3 in that one. All right, I'm going to count up how many parts I now have split that 4 up into. All right, I've now taken that 4 and I've divided it into thirds. So I now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer to that is 12. So there's our diagram. But again, we don't want you to doing that because it actually takes time and too much time. So we just want to know the rules and do this problem quickly. And if you guys always remember, with division, we think Kentucky Fried Chicken. Well, no, we don't. We think KFC. And that KC stands for keep the first fraction. Well, 4 is just a whole number. So if I'm going to write it as a fraction, I put it over 1. And I'm going to flip. All right, that's the F part of our keep, flip, change. I'm going to flip, so that becomes 3 over 1. And I'm going to change that division to times. And now I've got 4 times 3, which is 12, 1 times 1, which is 1, and 12 over 1 just equals 12. All right, so now let's just use the rule here. We've got 5, let's see if I can get that focused in there. 5 divided by 1/4. All right, so I've got 5. I'm just going to immediately write that as 5 over 1. All right, and I'm going to flip, so that becomes 4 over 1. And then I'm going to change the division to times. And I've got 20 over 1, which equals 20. And our last one is 1/4. Keep, flip. Now we just have the whole number 5. All right, so we do know that's 5 over 1. So to flip it, it becomes 1/5. And change that division to times. 1 times 1 is 1. 4 times 5 is 20. And the answer is 1/20. So 1/4 divided by 5 is a 20th. All right, so flip the page there and let's carry on. I am going to do this video in 4 parts. And so that you can stop and decide if you understand everything that we've talked about so far before you start the next video. But we are going to go and do number 2 as well before we stop this one. All right, so here we're going to multiply or divide using any method. So we get to choose here. All right, so here we have this 1 5/10 times 32. So there's few methods to solve this. I am just going to say, let's first use estimation to figure out what approximately is the answer going to be. All right, well, I have 1.5 can become 2, and then 32 can stay 30. You can, it can stay 32 because it's easy to multiply 32 by 2, or you can round it to 30. And we know the answer is going to be approximately 60 or approximately 64. That's going to help us determining where that decimal goes when we do it. So we now are going to do our 1.5 times 32. We're going to ignore that decimal for a minute because we're going to decide where it goes with our estimation here. So just pretend the decimal's not even there, and let's just do 15 times 32. 2 times 5 is 10. 2 times 1 plus my 1 is 3. All right, now that was 15 times 2. Now I'm going to do 15 times 30. All right, because it's times 30, we can't forget to put that 0 in the ones place there. 3 times 5 is 15. And 3 times 1 plus my 1 is 4. And then I add up and I get the digit 480. Well, that's not the answer, all right, because that's 15 times 32 is 480. We know the answer has to be somewhere closer to 60 than anything. So what number closest to 60? All right, well, it's not going to be 480. All right, we already know that. All right, so we think to ourselves, okay, is it 48? Is it 4 8/10? Is it 48 hundredths? Well, 48 is definitely the closest to 60. So our answer is 48. All right, let's look at the next one. Now, this one's fantastic because look at that. We have the same digits. All right, we still have the 1 and the 5 times the 3 and the 2. All right, but this time, instead of 1 5/10 times 32, we have 1 5/10 times 32 hundredths. So what we know about this is that we are going to be dealing with the digits 4, 8, 0, because we know 15 times 32 is 480. Now we have to determine where does that decimal go. Now this one's a little bit trickier because if you use estimation and we round that to 2 and 0 and 32 hundredths, if we just round to the units to the ones place, that's just going to round to 0. And 2 times 0 is 0. All right, so we know the answer is going to be somewhere around 0. Well, that leaves us a couple options. So we could take and just round our 32 hundredths to 3/10. All right, and 2 times 3/10, 2 times 3 is 6, is 6/10. So we know the answer has to be somewhere around 6/10. All right, or even better yet, we take and we just count our decimal places. 1, 2, and then we have another to make 3 there. So we're going to move our decimal 1, 2, 3 places. And the answer is 0 and 48 hundredths. which is close to 6/10, and close to 0 as well. But the reason why we didn't really know is that also 48 thousandths is close to 0 as well. So this one is closer though, so we got our 48 hundredths. All right, C, let's look at this one. This one now we have division. All right, so we have 12 divided by 3 hundredths. All right, well, let's just think about 12 divided by 3. 12 divided by 3 is 4. Well, I'm going to break that 12 up into even more parts than 3. I'm going to do 3 hundredths, even more parts than 3 tenths. All right, so I'm going to have even more. All right, so if I'm going to take 12 and divide it up into even more parts, than the 3 here, all right. Dividing it by a smaller number, which would leave me more parts. I said that wrong. All right, so we then have to decide where does that decimal go. All right, well, if it was 3 tenths, it would be 440. All right, and since it's 3 hundredths, the answer is going to be 400. Another way that we can think about that is 12 divided by 3 tenths. 3 hundredths. I'm going to keep messing up with this one. All right, we don't want decimal here. Okay, to show that, let's do it as a fraction. That's even better. 12 divided by 3 hundredths. All right, we never want a decimal, so we need to get rid of it. So I need to move that decimal 2 times and just make that 3. All right, to move that decimal 2 times, I need to multiply by 100. But if I'm going to multiply this by 100, I have to multiply this by 100 as well. So now what we have here is 1,200 divided by 3. All right, so the same thing would be there. We would just make that then a 3 because we're moving the decimal. Means we move the decimal 2 places this way, just like we did over here. 3 goes into the 12 4 times, nice and evenly. That 12 is used up. All right, and we just now have zeros. And another way to get that 400. I hope that explanation wasn't too confusing there. I said a couple things incorrectly. All right, so you might need to rewind and look at that one again. All right, we're almost done with part 1 of the video here. I'm trying to make this not too long, you guys. All right, so now we have the same thing here. Now we have 1 2 tenths divided by 3 tenths. All right, we know we're dealing with the digit 4 here, but let's write it as a fraction. Okay. Let's just change that division symbol to that fraction bar, and we have 1.2 over 0.3. We do not want a decimal. All right, so our goal is always get rid of that decimal. All right, when you're dividing. All right, get rid of that decimal. So how are we going to get rid of that decimal? We're going to need to move it 1 place and 1 place. So that means we're going to multiply both the numerator and the denominator by 10. That gives me 12 divided by 3. A hard problem at the start. It seems like it's difficult because you've got 1 2 tenths divided by 0.3, 3 tenths. All right, you might not be able to think of what the answer would be there. And we just then took that problem and multiplied the numerator and the denominator by 10 to make it a nice, easy 12 divided by 3. And the answer is 4. All right, so this one right here, all right, E, we have a decimal and a fraction. All right, so we have some choices here. We can change them all to decimals. We could split and break the number up to make it easier to work with. All right, I'm going to do the decimal first, all right? So, because I think a lot of you, that's what you would choose to do. And so we have 12 8 tenths times, and we all should know the decimal for 3 over 4. All right, and if you always forget, you can think of dollars. All right, if you had 4 quarters, all right, that makes up a whole dollar. So if you only had 3 of the quarters, it makes up 75 cents, 0.75. So I am going to multiply 12.8 times 0.75. So basically what we just want to do here is 128 times 75. All right, we're going to use estimation to figure out where that decimal goes. And again, that 75 hundredths just rounds to 0. That could round to 13. 13 times 0, anything times 0 is 0. So we know the answer is close to 0. All right, so estimation doesn't really help us as much as when we don't round something to 0. Let's just do the multiplication. We got 5 times 8, which is 40. 5 times 2, which is 10, plus my 4, which makes 14. And 5 times 1 is 5, plus my 1, I've used it, so I should really cross that out, is 6. All right, now multiplying by 70, because we're ignoring the decimals right now, so we're just pretending it's 128 times 75. So don't forget to put that 0 in. 7 times 8 is 56. I'm going to go right over top of that 4 because we'd already used that. 7 times 2 is 14, plus my 15 is 19. And 7 times 1 plus my 1 is 8. I am then going to add 0 plus 0 is 0. 6 plus 4 is 10. 9 plus the 1 is 10, plus my 6 is 16. And 8 plus 1 is 9. So 128 times 75 is 9,600. All right, well, the answer is not 9,600. All right, and I apologize. I said that the answer was going to be close to 0, and I just realized I made a mistake with that. We would not round 0.75 to 0. We round it to 1. That 7 right there would tell us that 0 would become a 1. And 13 times 1 is around 13. So we know the answer is around 13. So would 960 be closest to 13? Would 96? Would 9.6? Or would 96 hundredths? All right, and 9.6 would be our closest to 13. Or we can go back into the problem and count decimal places. 1, 2, 3. 1, 2, 3. All right, the answer is 9 6/10. We don't need to put those zeros in our answer. Okay, sorry, that was taking a long time, but we still have one more way to show this. All right, and I'm going to just show it to you really quickly, and I think some of you would really like this method because that took a little bit of time. All right, and then we had to use estimation. We realized that Miss Cook did the estimation incorrectly at the start. All right, we'd not round 75 hundredths to 0. We'd round it to 1. Anyway, let's go and look at one more method. All right, so what I'm going to do here is I am going to break up my 12 and 8/10. So I'm going to just do 12 times our 3/4. Then I'm going to do our 8/10 times 3/4, but I'm going to write my 8/10 as a fraction. Oops, forgot to write it as a fraction. 8/10 times 3/4. Now, once I get the answers to these two, I would just add them together. All right, so I could make this simple, and I could simplify first. 4 goes into 12 3 times, and 3 times 3 is 9. All right, or you could have done 12 times 3 is 36 and over 4, and 36 divided by 4 is also 9. But you need to get 9 there. This one right here, we have 8 times 3 is 24, and 10 times 4 is 40. Now, I could simplify here, and I could do 12 20ths. I could then look and see that both of those could be halved again and get 6/10. They could be halved again and get 3/5. And there's nothing further I can do with 3/5. So I have a 9 3/5. And my answer is 9 3/5. And those of you that know your decimals and fractions equivalents, we know that 3/5 is 0.6. So 9 6/10 equals the exact same thing as 9 3/5. They are equivalent to each other. So it's up to you. This method might be a little bit longer, but a lot of you just know how to multiply. So this is what you would choose. All right. Some of you can realize here that, whoa, breaking up that number into two parts, splitting up the 12 and the 8/10, and then multiplying both by 3/4 was actually much quicker. All right. Up to you. Which method did you like? All right. Last one. Last one is 102 4/10 divided by 33 2/10. So my first thing is whenever I have division and I have decimals, is I write it as a fraction. Then I realize I have to get rid of that decimal. If I multiply both of those numerators and denominators by 10, I can get rid of that decimal. So I have 1024 over 32. Now, there are two ways you can now solve this one. You could simplify this, all right, and we know that they're both evens, so we could just start halving, all right, until we get an answer. Or you could do the algorithm and do 1024 divided by 32. All right, I'm going to show you the simplifying version first, and then we'll do the other one. Half of 10,000, sorry, not 10,000. Half of 1,024 is 512, and half of 32 is 16. Half of 512, well, half of 500 is 250, and half of 12 is 6, so 250 plus that 6 is 256, and half of 16 is 8. All right, now I can ask myself again, can I just half? Yes, I can. They're evens. So half of 200 is 100. All right, half of 56 is 28. So that's 128 over, and half of 8 is 4. All right, I just want to double check that. Where did I write that there? I want to double check that one. So half of 200 was 100. I'm just going to write that in my head because I just wasn't 100% if I was correct on that. Half of 50 is 25. Half of 6 is 3. And I added all those together. And yes, it was 128. Just wanted to double check. Then half 128 is 64. And half of 4 is 2. And 64 divided by 2 is 32. All right, a lot of halving there, but halving is quite easy. I mean, this one was a little bit more work there, but it's a nice, good method. All right, working with fractions and then figuring out how to work with it from there. Now, the other way you could have done it is use the algorithm. And you would ask yourself, how many times does 32 go into 1? 0 times. How many times does 32 go into 10? 0 times. How many times does 32 go into 102? Well, we know that 30 times 3 is 90, and 30 times 4 is 120. So 4 would be too big, so the answer would be 3. 3 times 2 is 6, and 3 times 3 is 9. All right, and then I subtract. All right, that would have to be a 12 there. Or counting up. I love counting up, to be honest. 96 to get to 100 is 4. To then get to 102 is a total of 6. So we know the answer is 6. But if you're going to do it this way, 12 take away 6 is 0. And that 0 became a 9, and that 1 became a 0. A 9 take away 9 is 0. Still gets you your 6. And you bring down your 4. How many times does 32 go into 64? Exactly 2 times. 32 times 2 is 64. So that is your other way to get 32. So whichever method you liked best. All right, the next question is problem number 3, but I am going to do a new video for that because this has already been 23 minutes and I am a little bit tired and I need to think about taking a deep breath here. So if you got all of that, just go on and move on to video number 2. If you think you need to go over another problem, go back, go rewind and watch it again. All right, see you in part 2.